Hello, everyone. My name is Nitya Biyani, and I'm a Associate Solutions Architect at Amazon Web Services. My focus is on customers that are new to AWS. So I focus on building strong cloud foundations, putting the right governance and security and guardrails in place to ensure that my customers get started on their cloud journey on the right step. We have a variety of different solutions architects at AWS. I'm a field solutions architect, so I work closely with my customers to understand their business needs and challenges and also devise AWS solutions that can help them derive more value and business impact. Today, we'll be talking about AI assistance for smart manufacturing. But before we get into that, I want to set the scene a little bit and provide some context for this solution as well as the industry. So we will be going over looking at digital transformation in manufacturing, then looking at the architecture and the solution. I have a short demo, and then we look at the key takeaways and outcomes of the solution. Digital transformation in the manufacturing industry is still difficult. In manufacturing, whether it be automotive or food manufacturing, digital transformation is still challenging. Finding insights within manufacturing data is often challenging because most manufacturing data exists as unstructured data in the form of documents, equipment maintenance records, and data sheets. It's a still very manual process in certain factories. Finding insights in this data to unlock value is challenging because it requires considerable effort. Industrial transformation programs rely on collecting industrial data and building a strong data fabric or foundation that can drive decision making. It also involves breaking down the silos between the IT and operational technology or OT sectors because there are processes and systems that typically don't integrate with each other. And it involves gaining visibility into the enterprise and factory level, as there are a lot of manual processes and there's a lack of visibility due to just a lack of data collection. However, digital transformation can unlock a lot of value for customers. McKinsey reports that customers that have undergone digital transformation programs are seeing a 15 to 30% increase in worker productivity, almost 30 to 50% in reduction in machine downtime, a 10 to 30% increase in throughput, with a 10 to 20% improvement in that cost for quality. Yet, most 70% of manufacturers are unable to scale beyond pilots, and this can be for a variety of reasons. Digital transformation can mean a lot of things. It could mean that data fabric or foundation, as we discussed. It could mean enhanced automation on your factory floors or increased sustainability efforts to increase energy efficiency. But in essence, it is about bridging the gap between IT and OT, ensuring that your IT infrastructure and operational processes are connected and working together rather in silos. You can leverage your IT solutions to power operational activities, and the solution I am demonstrating today shows how you can leverage a GenAI solution in the cloud to make data more accessible and approachable to end users, such as shop floor operators, and help them troubleshoot and solve problems and production problems on the fly. So here we have an architecture for the AI assistant that I have deployed as a module in our open source cookie factory sample. The cookie factory sample solution is a fully customizable blueprint which builders can use to develop an operational digital twin or virtual representation tailored for manufacturing monitoring. The digital twin is powered by AWS IoT Twin Maker, and operational managers can use this twin to monitor live production status as well as go back in time to investigate historical events. This diagram illustrates the architecture of a cookie factory AI assistant module. Let me walk you through the key components and data flow. The user interacts with the dashboard app in their web browser. The app sends user requests to the AI assistant module, and then the AI assistant module retrieves the relevant data from a vector database to generate responses. The generated responses are then sent back and displayed in the dashboard app for the user. On the AWS side, The foundation models, including Claude and Titan, are hosted in Amazon Bedrock, a fully managed machine learning platform for training and deploying foundation models. AWS IoT Twin Maker is used to create a digital twin for virtual representation of the cookie factory equipment. It integrates data from various sources such as equipment manuals and equipment measurements. To collect that equipment data, IoT Sitewise is used, and it organizes and analyzes the factory's equipment measurements in real time. The solution also leverages Amazon S3 for scalable storage for equipment manuals, SOPs, and other custom data sources. Finally, AWS Lambda is used to stimulate the events that the AI assistant will be responding to and providing how to troubleshoot for the factory operator. The AI assistant module is a Python application that serves as user chat interface and hosts a large language model agent that responds to user input. The LLM agent is implemented using the LangChain framework. LangChain is a flexible library to construct complex workflows that leverage LLMs and additional tools to orchestrate tasks to respond to user inputs. Amazon Bedrock provides high-performing LLMs needed to power a solution, in this case, Claude from Anthropic and Amazon Titan. In order to implement the RAG or Retrieval Augmented Generation pattern, I have used an open-source in-memory vector database called Chroma. To better understand how this service works, let's go through a quick demo where I show you how the module is interacted with and how it provides input based on user input. So here you can see we're signing into the dashboard app as Spencer, a line operator in the Bakersville Central factory. And once it loads, you can see the digital twin of the factory floor that I've built using the cookie factory sample. We've identified an issue, and the cookie inspector seems to be rejecting more products than it's supposed to. So when we look at understanding what's gone wrong, we see that the cookies are misshapen. Here, once we run the diagnosis, the factory assistant will provide some common problems that may cause misshapen cookies, as well as some suggested next steps. So things like checking the temperature, examining the dough, seeing if there were any things in the dough that shouldn't have been there, if the mixing of the dough hasn't gone correctly. This assistant has been trained on the LLM that helps it understand what the most common problems are that could result in this deformation in the cookie and the cookie dough. Next, I need to inspect what the problem is and where the problem might be, so the assistant is able to talk me through this process as well. It'll walk me through the data and the various processes, looking at the different components to the production line, as well as show me a real-time view of the real-time data, as well as the processes going on the factory floor. So here we see some images of the cookies. We look at the different components of the factory floor and look at the data coming out of those. And what we can notice is that the freezer tunnel is facing temperature fluctuations. So now that we've identified that this is the issue, I need to also see what steps I need to take in order to fix the temperature fluctuation within the freezer tunnel. Asking the AI assistant this question, it's able to give me a step-by-step process on how to solve this problem. But more importantly, it also shows me the documentation and exact SOP from which it is pulling up these steps. Given that hallucination is a problem that's faced with AI assistants, this is a really crucial element that can help you solve the problem the right way. Finally, now that the issue has been solved, we see all the alarms go off and the processes are all back to normal. So as you've just seen in this demo, being able to quickly respond to breakdowns in the production line reduces the amount of time that machines are down and out of production. This in turn increases efficiency as operators are able to quickly respond and troubleshoot problems, so production is not reduced. And finally, you're able to provide more quality and have more quality checks with reducing the costs and reducing the number of manual processes required to assure the quality of your production line. So if you want to get started today, it's really simple. The cookie factory sample that I've used is open source and available on this GitHub repository. There's various components to the samples and as well as the AI assistant module. And then I also have the blog post on the AI assistant module from the team that's developed it, which talks you through the details of how the AI assistant was developed and how you can implement it if you wanted to and customize it the way I have today. Thank you for watching.